Okay, so we're still working on the IUPAC nomenclature process, which says we're going to work on step 2, find the longest or most important carbon chain, and we're going to use the root name. So right now what we're going to do is we're just going to practice identifying the longest carbon chain. So for some of these you might want to take some screenshots or just kind of follow along with me. All right. So I'm going to start from this end. 1, 2, number these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Get in the habit of numbering your carbons. And you could have started the other way. There. And in this case, we have 2 functional groups. This is a functional group here, and then we have several of these. Okay. We'll deal with that in a little bit. Okay, now, let's name this. Or not name it. We're just going to count carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here let's circle our functional groups. All right, let's do another one. 1, 2, 3, 4, 5, 6, 7, 8. Remember, the triple bonds are kind of tricky, so be really careful. Those are straight. So this is the first carbon, this is the second one. This one. 1, 2, 3, 4, 5, 6. Okay. Here we got some options here. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8. Or if I went this way, 5, 6, 7, you could also have 8 right there. Both of those would be okay. So you could have an 8 here or an 8 there. Let's look at this one. 1, 2, 3, 4, 5. And then we have this one. Or this can be your 5 and that one can be blank. Seven. 1, 2, 3, 4. Or you can do it 1, 2, 3, 4. I recommend writing these because when we get into some of these really complex ones, like this, it can be a little weird. So let me try this. 1, 2, 3, 4, 5. I bet I can do better than that. So that's an option. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. That wouldn't be long. 1, 2, 3, 4, 5, 6, 7, 6, 7. Any of those could be 7s. Okay. All right. So let's see. Oh, I got another one. Okay. 1, 2, 3, 4, 5, 6. It's in a ring, not anything else. Okay, so now what we need to do is we need to go back to our first one. And let's take a look here. And it's going to say use the root name. Now this is going to be kind of strange, but for this first one, but we're going to try it anyway. Because it says find the longest, most important carbon chain and use the root name. So this one's actually kind of broken in pieces. Yes, we have 20 carbons and we don't quite know the name for the 20 carbons. But do you see how we can separate this molecule into 4 carbons that have this acid on there, and the acid's the most important, and then we have everything else. So here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, whatever. 16. Several carbons. Okay, so this is 4 carbons, so this would be tetra. And I don't know what that other prefix is, but so this would be tetra, because that's what's associated with the most important. Now we go this one. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be a deca. Here, this is 8. This is going to be an oct. This is a 6. Oh, you couldn't see it. That's an oct. This is a 6. This is going to be a hex. This is an 8. It's going to be another oct. This is a 5, so it's going to be a pent. This has 4, so that's going to be bute. This is 7, so it's going to be hept. And this one is 6, but they're in a ring, so this is going to be cyclohex. So that's what we're doing, identifying longest and most important carbon chains. So you might need some more practice with that.